Good day, everyone, and once again we're back together. So we're looking at geometry this time, Euclidean geometry. So of course, if you haven't subscribed, hey, what have you been waiting for, right? So we jump into the November 2022 exam, right? Let's have a look at it. So they say in the diagram we've got O, which is the center. So when you're working with Euclidean geometry, I always like to work within the diagram. So as soon as they tell me that we've got a center, what I normally do is that I just indicate where my radii are, because sometimes you may find that you've got an isosceles triangle, just waiting for you there. Right, so they say M and PR is a cyclic quad. Okay, so that's M, N, P, and R. Okay, we can see that's a cyclic quad there. Very important because I'm already seeing an angle there of 64. So if I use the opposite angles of a cyclic quad, right, we know they are supplementary. So in this case, it means M2 and angle P, will form 180 degrees. And so angle P should be 180 minus 64. That should give us what? 100 and, shall we say 16? 116 degrees. Okay. Right. So I'm working within the diagram before they even ask me any questions, right? And then what else do I see there? They say SN is a diameter of the circle. Oh, beautiful. Because what that does is that it makes this entire angle to be equal to 90 degrees. Remember, that's angle at semicircle, right? So if that's 64 and that entire angle is 90, it makes the angle M1 90 minus 64. That should be what, 26 degrees, right? So that should be 26 degrees. That is M1, and I can already see something over there, that I will get another angle which is O1. Can you see? That's angle at center is twice angle at circumference, because they are subtended by the same arc there. So as a result, it means that O1 will be twice 26. Okay, and twice of 26, that should give us 52 degrees. Right, anything else that we can note on that diagram? Okay, well, nothing else necessarily. Okay, let's have a look at what questions they asked there. So they say determine, giving reasons, the size of the following angles, right? So they looked for angle P, right? So we're going to say, well, angle M2 plus P equal to 180 degrees. So we're going to say for that particular one, that's 8.1.1, angle M, is it M2 plus P would give us 180 degrees. We are going to say opposite angles of a cyclic quad. Okay, quad. All right, and therefore that means that angle P will be equal to 180 minus 64, and that's how we're able to get that 116 degrees in that case. So that's the value of P. Right, so that's 8.1.2. How are we going to get that value there? Right, so they're looking for M1. Okay, you remember how we went about M1, right? So we said, okay, in this case, we know that M1 plus M2 are equal to 90 degrees, and that is because SN is a diameter, right? So we're going to use angle at semicircle. So remember, M1 plus M2, right, are equal to 90 degrees. Okay, we said angle at semicircle. Okay, semicircle. All right, or you can say angle subtended by diameter. So we already know the value of M2 to be 64, so we can find the value of M1 will be 90 minus 64, and we found that to be 26 degrees. All right, so we've got the value of M1, and finally we are looking for O1, okay, which is the one that we found there, right? So in this case, we know that angle at center, right, there's our center there, our center O. They told us that it is the center. So in this case, there's the angle at circumference, which is M1, right? So we know that O1 will be 2 times. So O1 will be 2 times M1, okay? And why is that? Angle at center equals 2 times angle at circumference, okay? I'll just say angle at circle, right? So in this case, we know that O1 would therefore be 2 times 26, and that would give us 52 degrees. Okay, and that essentially, ladies and gents, is how the cookie crumbles in this question, right? I want to treat the other ones separately, and I'll do that in the next video.